Unit 12.2, creating arrays. I'm going to create the ones that are above here, and then I'm going to actually create some new ones. There are 4 ways to create the arrays, so I'm going to go ahead and show that. Let's do the array 1. Array 1, realize I'm not writing the square bracket again. Realize I'm not writing int again because it was already declared. I'm going to say new integer, and I'm going to say 6. I just created an array that holds 6 integers. What is the reason for an array? An array can hold many pieces of data as opposed to using variables, right? What if I wanted to write 6 variables? I could have int x, int y, int z, right? This is gonna be long. Well, especially if I wanted 100. See, just one little statement made 100 slots for different variables, and they can change, they can update variable. But if I was to do it this way, it would be long. So an array is a compact way of making a lot of data points such that we could use it in our app. So sometimes we need to make things a lot more compact and easier to write and easier to read, especially if they're all common, like they're all integers. So why should I be writing that many names? So I have 6. I'm going to just do any number of data points here. So I'm going to say new double. Realize how I'm writing this. New double. Let me put in 7 things in this. And then the string 1 is array 3. It's new string. I hope you're picking up the idea. The type is important. Put 8. I'm just going up by 1 here. And then I have the last one is array 4. The name of the array and the type. Okay, these numbers just mean this means 6 slots, 0 to 5. 7 slots, 0 to 6. 8 slots, 0 to 7. 9 slots, 0 to 8. Remember, off by 1. So this is one way to create an array. You declare it first, then you make it after. The other way would be, we could do it all in one, right? I could just go ahead and make an array immediately. Let's say I wanted to make an array of integers. I'm going to call this array 5. I could do it immediately, new int, and then put 10 things in there. This is doing these 2 steps in one stop. One step. Shouldn't say stop. One step, do these 2 things. Declaring it and creating it. Now, question. What are in these arrays? Well, we have 6 spots, but what's in each spot? Well, there's something known as, don't say nothing. There's no such thing as nothing in a computer. This is going to hold a 0 in every spot. And specifically the number 0. So every spot in this first one has a 0. What about this one? This one is going to hold 0.0 in every spot. What about this one? It's going to hold null, no strings yet. And this one is going to hold false. I know you were wondering about that one. It's Boolean. It has to be false or true, and it holds false. Why? False is for 0. You should get a theme here. The idea is, how do you represent nothing? Well, nothing is represented differently in data types. In an integer, nothing is 0. In a double, it's 0.0. In a string, it's null, and in a Boolean, it's false, because false is 0 and true is 1. They're bits. So right now, I just made an array called array 5, and it holds 10 integers, and every single one slot has a 0 there. Okay? So what I'm going to do now is, I'm not going to necessarily show you every single one of these in terms of how to populate them. We just created them. They all have zeros, but we want to put stuff in them. So that's the whole idea, is to put values in. So let me just work with array 5. So suppose I wanted to put, hey array 5, I want you at position 0. I would like you to put a 1 there. Okay? So right there you can tell right now I'm starting to put values in array 5. And then I could go ahead and say array 5 in position 1, I want you to put the number 2. And in position 2, I want you to put the number 3. And in position 3, I want you to put the number 4. So at this point, 0, 1, 2, 3 is going to have 1, 2, 3, 4. Every other spot has a 0. Okay, so what if I wanted to put a number in every spot? Well, I'll just have to do this. So I'm going to say that's 3 got filled, 4 put a 5, and 5 put a 6, and 6 put a 7, and 7 put an 8. You can tell right now there's a little pattern going on, if you could see it. It's almost like a +1. What if I put a 10? And then put a 11. Right? This is an issue. Because this thing went up to 10, it went 0 to 9. I should have stopped here. There is no 10 spot, and there is no 11 spots. You know what's going to happen to these? We're going to get an error. It's going to say out of bounds, and it's going to tell me on index 10. Let me run it. Out of bounds. 10. Where did that happen? Didn't even get to the 11th one. Right here. Okay, so you have to be real careful of array index out of bounds exception. It suggests whatever you're working with this array, you went out of bounds. Now you could go out of bounds on both ends, on the right side, the positive, and on the negative, right? You can't have a negative number. Let's just try that. How about, let's just put one at the negative first index. This doesn't make any sense, but let's just run it. It's going to tell you at -1. So we must start at 0, and we're going to stop at 1 less than the length. Any other thing is out of bounds. No index besides those are going to work. Okay. Obviously, if I run this right now, nothing's going to happen because I didn't really do anything. So why don't I go ahead and show you that I could print them. Alright, so now we're printing these arrays. So I'm going to say here, array 5. Print the value at, see, quite the same idea here, at 3. So this array 5 is going to print the guy at 3. It should print a 4. Let's do that. Perfect. So there are two ways to see this then. If you want to change the value at a specific spot, you write it like this. You get the value for the correct index, a valid index, and you assign it the right type. See, I can't put a name here, okay? I can't say, put lake. That's not going to work because this is an array of ints. I can't put a name. I can't put a string there. If I wanted to, I got to make an array of strings. So put the right type, assign it to that spot, and that spot that was once 0 changes. Yeah, so if I go ahead right now and I say array at array 5 at position 3, change it to 20. You know what's going to happen? It's going to print 20. Because array 3 was a 4, but then it changed. Memory is destructive. See? Array 3 is no longer a 4. So that's one of the things that get a lot of people all tripped up here is when you work with an array, sometimes you change a spot and you're thinking of the value from before that. You got to make sure you realize when the change happens, the new value is now in that spot. What happened to the old one? Completely lost. Erased from memory. So in this case here with 3, this 4 that used to be in that slot is nowhere to be found. Completely lost. So this is one way of making an array. Told you there are 4 ways, so let me just keep adding. I'm going to go to array 6. Int array 6. I'm putting in the same values here. Let me go ahead and take out this 20. I don't want to change that spot. So I'm going to say array 6. I'm going to set him equal to new integer Look at that. This is a little bit weird here because see what I did there? This is doing this all in one slot. Keep saying slot. All in one line of code. So what that means then, saying slot, I'm trying to say shot. All in one shot. Right here, this array 6 is actually doing all of that. It made a guy with 10 slots. How do I know? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it put the values right in immediately. There is another way. Not done. Not done at all. Let's go for array 7. Now, obviously, I'm only using integers here just to show this, but this is going to hold true for any type. If there was a string, all that changes is the name of the type here. The type would change to string, and obviously the data would match whatever you're doing. So I'm going to go ahead and show you another way to do this. Mind blown. Yeah, we don't need this. Now, at this point, you should say, wait a minute. If we have all these ways, then what's the reason for all this flexibility? If you want to type this up, go ahead and do it. I prefer this because less typing, but it reminds you that you're making an array of integers and putting these values in. You don't have to say that. The system could infer this from the type that follows. I said 4, so I got more. Here we go. Int array 8. I'm going to make you hold 10 things, but look what I'm about to do. I'm about to write a loop. I less than array 8 dot length. See, the API already has that, which is nice because I don't have to figure out how many things are in the array. Just put dot length on the name of the array and it will tell me it's 10 in this case. So here's what I'm going to say. I'm going to say, hey, array 8, at position I, put I plus 1. And this is what I was talking about when I said if you see the example here and you see the pattern. I, at position 0, put a 1. So when I is 0, it's going to do 0 plus 1. And in the position 0, 1 is going to get set there. See? 1 way, 2, 3, 4. This is known as the manual way. Do it manually. This and that, same idea. These are done from initialization. So if you know exactly what needs to go into the array before you start, these two are good. Sometimes you don't. And this and that wins. If you know the pattern, you'll put them in. If you don't know the pattern, you may have to do it manually, or at least some of them manually. Generally, though, we do know a pattern, so we'll be able to use a loop to do that. Again, let me walk through this. Int I equals 0, I less than 10 slots, and we're going by 1. So when I is 0, I'm going to get a 1. Put a 1 in the 0 spot. I is 0, then I plus plus, I becomes 1. 1 plus 1 is 2. Put a 2 in the 1 spot. It should be following up here. This is I inside, and this is I plus 1 on the outside here, assigning. 8 assigns 9. 9 assigns 10. 4 ways to create an array. This is creating arrays. Remember, the index that you're seeing, sometimes it's the size, and sometimes it's the index. That's not one that gets a little confusing. If you're actually making it and the stuff is on the right side, these values, these are lengths. These are not indices or an index. This is the length. This is saying there are 6 things in this array. 7 in this one, and 8 in this one, and 9 in this one. 10 in this one, This is an index. This is asking for the value at spot 3. So be careful. When you're on the right side and you see a number, that's length. But when you're dealing on the left side, or if you're just using the value, then that's actually the value at that spot. All right, I'm going to do a couple of things. So what I want to do is print the array. So you see this array 8. I can print it. How can I print it? I'm going to use the same loop because the array now fills up with stuff. So I'm going to go ahead and print it. I'm going to print it horizontally. So how am I going to print it? Well, I'm going to say at array A at position I plus a space. And if I run that, what you'll see, you know what, I did ln and I needed to do without the ln. So if I run this, you would see the array 8 printed, see? Going right across. I printed every single spot because what I did is I say print every I, put a space after. One more thing that I want to do is I want to show some calculations. So for example, I can say array 8 at position 3, put array 8 at position 0 times array 8 at position 1. See, this is what you call calculating, doing stuff with the array itself. So you got to remember how the array looks. Once this calculation happens though, these two values are used to update the guy in 3. Every other spot remains the same. Okay, so right now the 0 has a 1, the 1 has a 2. So if I'm multiplying these two things, I'll get a 2, and I'm putting a 2 in position 3. So if I go ahead and print the array again, if I go ahead and print it again, it would have a different guy in position 3. Let me go ahead and print a new line so we could see the two different things. This one needs an ln. So let's go ahead and check that out now. Let's look carefully. You would see the original array was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But the other one is 1, 2, 3, 2 in position 3. I know you're wondering how. Position 3? Yeah. 0, 1, 2, 3. I took these two, multiplied them, and changed the guy over here. So that's something that's very crucial to be able to do some math with this. How about if I say array 8 at position 5 plus equal array 8 at position 9 mod array 8 at position 3. It's the kind of questions I'll be asking. So what does the array look like now? Let's run it and check it out. So 3 and 5 changes. 3 changes to a 2. 0, 1, 2, 3, 4, 5. 5 changes to a 5 did not change. Let's see what happened there. So we got 5 to be add on this value. So let's go array at position 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Mod the guy at 3, 0, 1, 2, 3. Aha, it's a 2. So 10 mod 2 is 0. No wonder it didn't change, right? I mean, that's why it didn't change, because we added on 0 to the 6. Now what if I change this to 2? Let's check that out. Now it changes to a 7. Let's see how that works. 0, 1, 2. 10 mod 3 is 1. Add a 1 onto the 6, we get a 7. So we could do quite a number of things with these. We could print them. We could change the values. We could do printing them backwards and forwards. How about we print it backwards? Let me try print backwards. So I'm going to use a loop again, and I'm going to print the array 8 backwards. So I don't want to start at 0. No, I want to start at array 8.length minus 1. Remember, the last guy is in length minus 1, not length. And this guy must be greater than or equal to 0. And we are going backwards, so we are minus minus. I'm going to print a line between these so that we don't mix them up. And yes, once we do that, see, look at backwards. Right, we're starting at the last guy, we're stopping at the 0, and we're going minus minus, going back. See, this is the guy forward, and this is him backwards. So, when you're working with arrays, we got to remember each spot, each index can change. We can do math with it. We could add 1, subtract, multiply, do whatever if it's integers. If it's strings, we could change the names that are there, put a new one in, take it out, whatever. So the good part about this is that we could do a lot with very little code, right? Like I could make a loop that changes every value in here by adding 6 to it, let's say, or multiplying every one by 2 or something like that. See, if I needed to do this with variables, it'll take a long time because I'll have to make 10 variables and then I have to go multiply each one. So it would take long. So an array is a way to compact your data into a nice list, especially if it's related data. And then you could work on them using loops. And that's literally what we are going to be doing, mostly working with the loops on them, because since it's that many, we need to use a loop. Again, this is how we create them. This is how we populate them. Let's take a look. So we're creating 4 ways. Choose the one that makes sense to you. It's not always that you can use either one. You have to look at the app and make that judgment. And then once we come down here, we see that we could do stuff with them. Print, change, update, and so on. 12.2. 12.2. Creating arrays. That brings us to the end of 12.2.